How's it going, everybody? We're going to be doing transformations in this video, and it's specifically going to address how to do transformations of the parent functions that we studied this past Monday, and also too maybe doing a couple of transformations of some other functions as well. So let's go ahead and get started. So this first one that we have right here, okay, is telling us that we're going to do up C. Okay, now that up C could literally mean like a 3, could be a 4. Okay, but the idea is that plus C tells us that we're going up. Okay, and we're going to be adding that to our y. So we're going to be adding to y. Okay, now conversely, if we have minus C, we're going to be going down C units. And so that's going to be subtracting. Subtracting y. Okay. Now the inside, so say that C goes ahead and jumps inside of the parentheses, that is actually telling us that we're going to be going to the left C. And I know in our head it kind of makes us think that, you know, we should actually be going to the right because it's a plus, but this x value, when it's inside the parentheses, is a liar. Okay, it lies to us. And so when you see x plus c, that means you're going to the left. Now that means we're going to be subtracting not our y, but actually our x. Okay, we're going to be subtracting x. Now if you have an x minus c, instead of going left, you're going to be going right now. Okay, you're going to be going right C units, okay? And now we're going to be adding x. Okay, we're going to be adding our x. Now, moving further to the a times f, this right here is going to be a, a vertical stretch, okay? So this is called a vertical stretch. And what we're going to do is we're going to go ahead and multiply the y. Okay, we're going to be multiplying the y with that. The next one, the 1 over a, is we're going to be doing a vertical compression now. And once again, we're going to be multiplying, okay, the y. Now, these transformations, as I'm going through them, will make more sense as we go ahead and do some examples. But for now, let's go ahead and get all of our ideas down, okay? So that's what we're doing right now. So now our 1 over a, no, not 1 over a. We're talking about our negative now. Our negative right here, this is going to be talking about a reflection, okay? This is going to be a reflection across the x-axis. Okay. And once again, when you do a reflection across the x-axis, we're going to also multiply the y. Okay, we're going to multiply the y. Now, this bottom stuff right here, this is going to be this 1 over b. You'll notice the difference here is this is going to be a horizontal, and the difference is the 1 over b is inside the parentheses, okay? Notice how over here, 1 over a, he's outside, 1 over b right here is on the inside. So this is a horizontal stretch, okay, by b. And what we're going to go ahead and do is we're going to multiply the b to our x, okay? So we're going to multiply the x, okay? Now, the next one is a horizontal compression, okay? And I'll shorten it by C-O-M-P. It's a horizontal compression, and we're going to multiply it by 1 over b, okay? And we will multiply the x. Now, you'll probably be looking at this and going thinking, well, Mr. Farmer, it looks like you swapped them. But it actually, the way the horizontal stretch and the horizontal compression work, if you have a 1 over b, you're going to multiply your x by the denominator. And if you have a multiplying by a b and you're doing a compression, you're going to be multiplying your x by the reciprocal, the 1 over b, okay? So that part right there is how we're going to address. Now this last part, okay, this is where the negative is now inside of the parentheses. Notice how over here at number 7, it's jumped outside, but here for number 10, instead of reflecting across the x-axis, this will reflect across the y. So reflect across y-axis, okay? And this will be simply done by multiplying by the x, okay? Now, like I said, what we're going to do is we're going to take these ideas, okay, and we're going to go ahead and apply them to these graphs down here, okay? Now, looking at these examples right here, what we're going to do is this right here, this first one, this given, okay, this one that has a star, this guy, this is what we're going to start with. Numbers 1 and 2, okay, those are going to be the transformations that we're going to apply to this little h of x over here, okay? So we have this weird looking graph, okay? It looks like it goes straight up, curves, comes down again, and then jets off to the side. So what I'm going to go ahead and do is I'm going to get some points from this thing. So I have -3, oh, my pen, there it goes, -3, comma 0. I've got -2, comma 1. I've got -1, comma, looks like 2. And then I'll get another point on the right hand side. I've got 1, comma 2. And then I've got, I'll do the next one. I've got 3, comma -1. I'll do that one. Alrighty, so here we go. So if I were to go ahead and to plot this, okay, into my transformation, I'm going to make sure that I follow this idea of PEMDAS, okay? Remember, PEMDAS, we have to make sure we do our multiplication first, and then we do our adding and subtracting, okay? So looking at this equation right here, I'll go ahead and transfer my points into here. Okay, just like this. Alrighty, I think that looks pretty darn good. Okay, so let's keep going. So it says here first that I'm going to go ahead and multiply by a negative, okay, on the outside. Now if we kind of go back over here, it says, it says that we need to go ahead and do number 7, which is reflection across the x-axis, and we need to multiply the y. So let's go over here. Let's multiply the y, okay? And it looks like it's just going to be a -1, okay? Just by a -1. So let's go ahead and do it. So the x's, they go ahead and stay the same. Nothing to see, nothing to do. But now let's change the y. So 0 times -1 is going to be 0. 1 times -1 is -1. -1 times 2 is -2. -1 times 2 is -2. -1 times -1 is going to be +1. Now, after we've done all the multiplying, we need to go ahead and add and subtract. Now, you'll notice that there's an x minus 3 in here. If we go back to our table, we'll notice that if I see my x minus c, I need to go to the right c. So that means I have to add x, okay? Now, I know what you're thinking. It makes you want to say, oh no, we need to subtract 3. But we can't trust the x, right? We got to make sure that we add 3. Now, of course, the y, we go ahead, if you look up top at the chart again, it says that we need to go ahead and just add 2. Okay, so we can trust the y. The y is okay. So let's go ahead and do that. So I've got -3 plus 3, that's going to be 0. I've got -2 plus 3, that's going to be +1. I've got 3 plus -1, that's going to be 2. 3 plus 1 is 4. 3 plus 3, that's going to give me a 6. Now let's go ahead and do the y's. I've got 0 plus 2 is finally 2. 2 plus -1 is 1. 2 plus -2 is 0. 2 plus also another -2, that's going to be 0. And then I've got a 2 plus a 1. So, oh, that's not going to be 2 plus a 1 is going to be a 3. There we go. Now, what I'm going to do is I'm going to take this last table and I'm going to actually plot these points. So I'm going to go to 0, -2, that's, or 0, 2, so that's going to be right about here. Then I'm going to do the next point, 1, 1. And then I'm going to have 2, 0, okay? Now, it was at this point in time that we had that little U-shaped thing, and it went ahead and it curved on around. It looks something like this, okay? It was that little thick piece, okay? And then it hits our point 4, 0. And then we got another point, 6, 3. So 1, 2, 3. 1, 2, 3. There we go. Okay. And so we had something that looked like this, okay? And then we draw it, okay? So what we can see here is that we have a transformation of this one on the given, right? We've gone ahead, we took that H and we recreated it. Now, of course, if you're a better artist, you'll definitely make that look a lot nicer, okay? But you can notice that we've made those transformations, okay? Made it into the what number 1 wanted. Now let's take a look at number 2. Let's do the same thing, okay? Give it some more practice. So the points that I'm using are -3, 0. I've got -2, 1. I've got -1, 2. I've got 1, 2, 3, -1. Alrighty, so let's go ahead and apply these transformations. Now remember, according to PEMDAS, we got to go ahead and we got to multiply and then we got to add, okay? Now, looking at this right here, we have a 2 in the front, okay? So let's go ahead, come over here. What does it say to do when I have a value in the front? Well, it says that's number 5. That's a vertical stretch, and I need to go ahead and just multiply my y. So coming on over here, okay, I'm going to take my y value and I'm going to multiply it by 2, okay? So my x's, they're not going to change, so I leave them alone. Okay, now let's go ahead and multiply. 2 times 0 is still 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 2 is 4 again. And then 2 times a -1 is -2. Now let's look and see what we got to do next. Now we see a +2. If you were to look up in the chart, you'll notice when we have a +c, we are going to the left. So that means we have to subtract. So we got to make sure that we're careful not to go ahead and add to. Remember, don't trust your x. Now, of course, there's nothing out here for our y, so we're not going to do anything to the y. We're not going to add or subtract, so we leave those alone. So I've got 0, 2, 4, 4, and -2. Now let's go ahead and add. So -3 minus 2, that's going to be -5. -2 minus 2, that's -4. -2 minus 1 is -3. -2 plus 1, that's going to be a -1. And then we have 3 minus 2, that's going to give us a 1. Okay, so let's go ahead and plot these points. So I've got -5, 0, so that's going to be right there. I've got -4, 2 right here. And then I've got -3 up 4. Okay, and then I've got -1, 4. Okay, and then I've got 1 down -2. And what you'll notice about this, okay, oh, not like that. Let me try this again. Okay, is that our graph got very skinny, okay? It got very skinny and it started to stretch up, which is exactly what we did, okay? That's exactly what the 2 is going to do, okay? It's going to make everything look a little bit taller. And so if we zoom out, you'll notice that it still appears to look like this beginning function over here, this h of x, but now we've done some transformations to it, okay? We've gone ahead and modified it a little bit to make it a little bit taller and to move it to the left. Now, if we were to talk about the domain and range now of each function, we can see the differences. So the domain for the first one, the farthest left, is going to be -3. And we're going to put a bracket. And then it goes to +3 and then a bracket. Now the range goes from -1, and then it goes to +3. Okay. Now let's take a look at the next one over here, number 1. Okay, and let me get these out of the way so that way I don't mess things up a little. Let me just get these. Guess I can't erase them. I guess I'll just have to leave them there. Alrighty, no worries. So I have 0, okay, to +6. Okay. And then I have my range goes to about -1 to +3. Now, what you'll notice about this graph is the domain shifted ever so slightly. We said that we moved number 1, that x minus 3 up top, we moved it to the right 3 units. Well, guys, look at the domain for the first one. What's -3 plus 3? That's clearly 0. Now look at the next part of the domain. What's 3 plus 3? That's clearly 6. And just to go ahead and kind of even emphasize it more, I'm talking about this 3, right? -3 plus 3 is 0. And then if you do 3 plus the 3 that's up here, right? That's going to give us 6, okay? So we can see that everything adjusted well. Now, of course, the range is very coincidental, okay? The range is not going to stay the same like that every time, okay? It just so happened to work out that way. Now, we can also maybe see some similarities with the next set of domain and range. Let me see. We have a -5 all the way to +1. And then it looks like we went from -2 to about a 6. Boom. And so looking at that right there, that makes a lot of sense because the whole idea was we wanted to move this graph to the left 2 units, right? Want to move it to the left. So if you take -3 over here, you subtract 2, what do you get? You get -5. If you take 3 over here and you subtract 2, you get +1. Okay, and so as you can see, you can notice even within the domain, you can see how the transformations apply. Okay, we can see how the graph moves. So let's go ahead and now take a look at some more examples. Okay. Alrighty, so this next part, what we're going to go ahead and do is describe the transformations and sketch the graph. Okay, and describe the domain and range and assume you have your foldable. Okay. Now, what does it mean by the foldable? It means the parent functions that we created on Monday, okay, those 9 equations. And so what we have to be able to do is use that foldable. So if you have that foldable right now, what you can do is pause the video and see if you can figure out, okay, what this guy's parent function is, okay? So go ahead and pause it now and see if you can find it, okay? Now, continuing on in the video, the parent function for this guy, if you found it, was y equals your x squared, okay? Because you'll notice that x squared is in there. It just has some transformations done to it. The minus on the outside, that's telling us that we are going to reflect, okay? And what I can do is I'm going to go ahead and zoom in a little bit so I can write better. We're going to reflect across... I don't know what happened there. Let me try it again. Across the x-axis. And then the +2, remember it lies to us, so we went to the left 2 units. And then we're going to go down 1 unit, okay? So that right there is going to be the transformations that I'm going to do. Now, if you look at your foldable still, what were the initial points for an x squared? Well, if we look at the beginning points, if you had a -2, that would give you a +4. If you had a -1, that would give you a +1. 0 would be 0. And then 1 is 1, and then 2 is 4, okay? So those are the initial points, okay, for a quadratic function. Now let's go ahead and apply the transformations. The first thing we have to do is reflect across the x-axis, because remember, we have to multiply and then we have to add, okay? So looking at this right here, we're going to multiply by a negative 1, okay? And nothing's going to happen to my x right now, so we got negative 2, negative 1, 0, 1, and 2. Now my y's, 4 times negative 1 is negative 4, 1 times negative 1 is negative 1, 0 times negative 1 is 0, 1 times negative 1 is negative 1, 4 times negative 1 is negative 4. Now let's go ahead and apply the other transformations. Okay, so if I have a plus 2, that means I'm going to have a minus 2. And then, of course, the y, it's actually telling the truth, so we're going to go down 1 unit. Okay, so looking at my x's, I got negative 2 minus 2, that's going to be negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is going to be negative 2. 1 minus 2 is going to be negative 1. And then 2 minus 2, that is going to be a 0. Now let's do the y's. That gives me negative 5. That's going to give me negative 2. That's going to give me negative 1. That's going to give me minus 2. And this is going to give me a negative 5. Okay. So now let's take this last table right here and let's plot the points. So I've got negative 4, negative 5. So 1, 2, 3, 4, 5. So I got a point right here. And then I have a negative 3, 2, negative 3, negative 2. So 1, 2, 3, then 1, 2. Okay, about here. And then I have a negative 2, comma, negative 1. So I have a, let me see, negative 2, down 1. So about right here. And then I've got a, let's see here, negative 1, negative 2, about right here. And then I've got a 0, negative 5. So what you'll notice is this quadratic has been flipped over, okay? We've reflected it across the x-axis, okay? And we've shifted it to the left 2 units and down 1 unit. Now, for those of you who are maybe still kind of trying to figure out what this whole reflection business means, when I say reflect across the x-axis, let's kind of take a look at the original. So the original x parent function x squared looks something like this, right? Now, I did a poor drawing of it, but it initially looks like this, okay? Now, if I wanted to reflect it across the x-axis, okay, it's going to flip over, okay? It's going to flip over. And it's now going to be flipping down, okay? Now, if I wanted to flip it across the y-axis, okay, you'll notice it'll actually stay the same, but that's the idea. When I say reflect across the x-axis, I mean that it's flipping down, okay? Instead of being up, it'll go down now. Now, we'll, of course, practice with other functions, and you'll get to see more of that in a second. So just stay tuned. Let's keep going. Alrighty, so this next one, okay, it says describe the transformations, sketch the parent function and the new function. Assume you don't have your foldable. Okay. So basically what we're going to do is we're just going to do a rough sketch. If you guys remember 1 over x, it looks something like this. Okay. And it had some asymptotes, right? It had some that you couldn't cross the x or y axis, okay? You weren't allowed to cross this, okay? You get close to it, but you can never cross it. Now, what it goes on to say here is that we have a negative on the outside, so I'm going to reflect across x-axis. And then it looks like here that I'm going to be going to the left, or to the right 2, because the x lies, so I'm going to be going right 2 units, so 2, and then units, and then the y always tells the truth, so I'm going to be going up 3, okay? All right, now let's go ahead and apply these transformations, okay? So if you look at this, The asymptotes are also going to move to the right 2 units and up 3 units, okay? So if I were to go ahead and kind of simulate that, okay? So going up 3 units, okay, for this thing. And then it also goes to the right 2 units. So it'll look something like this, okay? So that's like the new X and Y axis, okay? That red part. Now the graph itself, okay, we just got done saying that he also reflects and moves to the right. Now when I say reflect, that means it curves the opposite way. So this top part now goes to the bottom, and this bottom part right here goes to the top. Now, of course, like I said, we're going to be doing a lot more practice with these, so these types of functions will get a little bit easier. Okay, but that's the idea, is that we're going to reflect, move to the right 2 units, and up 3. Okay, and you'll notice that the asymptotes, which is in red, also adjust as well. Now let's kind of take a look at number 5. Okay, it says, for each description below, write the equation for the new function using the described transformations. Okay, let g of x be a vertical compression by a factor of 2/3 with a translation 3 units left and 2 units up from the graph. So remember, we go ahead and we apply the multiplication first. So I have 2/3 times my negative square root of x minus 6. So that's going to give me negative 2/3 square root of x. And then that's going to give me 2 times 6, that's 12, divided by 3, that's going to be a minus 4. So boom. And then there we go. That's what we have so far. Now what we're going to do next is we're going to do with a translation of 3 units left. So if I want to go left, that means I'm going to add to the x. So that means I have a negative 2/3 square root of x plus 3, because I'm adding to the x because I want to go left. And then to go 2 units up, I'm going to basically add 2 to the 4, to the negative 4. So that's going to give me a minus 2 there. Okay, so that will be my new g of x function, is negative 2/3 square root of x plus 3 minus 2. Okay, so that's the first one. Let's take a look at the next one. It says here that we've got this f of x right here, okay, and we're going to do a vertical stretch of 2 with a translation 2 units right and 4 units down. So let me see here. I got 5 to the x plus 4. We're going to multiply by 2, okay? Now, when you multiply this 2 on in, okay, you're not going to do 2 times 5. I know it's very attractive to maybe do that, but we're actually going to keep them separate, because with exponential functions, you keep the exponential, okay, the e or the 5, whatever it may be, you keep them separate. But 2 times 4, we can do that. That's going to give us 8. Now, let's go ahead and do with a translation of 2 units to the right. So if I want to go to the right, that means I have to subtract. So I have x minus 2 and 4 units down. So that means I need to subtract 4 from this 8. So I have let's see, 8 minus 4, that's going to be plus 4. Okay, so that's my new function. That's my new g of x. So I have 2 times 5 to the x minus 2 plus 4. Okay, and so that is how we go ahead and write in those transformations to the f of x's. Okay, so if you have any questions, please let me know, guys. Thank you for tuning in. I'll see you tomorrow, and we'll do a lot of practice. Here we go.